percent purity. So if you have a compound, unless you're told different, you can assume that it's 100% pure. That if you have salt, it's all either sodium or chloride molecules. Um, but in real life, it doesn't often work that way. Even the stuff we buy from the laboratory is often like 95% pure. And, if you check like a bottle of multivitamins or a bottle of aspirin or something, you'll find that, very little of it is the active ingredient, and most of it is what they call inert filler. And so we can use the idea of percent composition to illustrate that. So they refer to this on AP Chem as the percent purity. So consider that if you have a compound, that's going to be 100% pure. Okay? And so what we have figured out so far from our last problem is that sodium carbonate, if you have 100% sodium carbonate, it should be 43.4% sodium. Okay? So the question you would get on a quiz or a test or something like that is, say you have a mixture of sodium carbonate and some inert ingredient. It doesn't matter what it is. It could be potassium chloride, just so long as it's not sodium or carbonate, because that's going to throw off your percentages. Okay? So what you've got here, as long as you know that if it's 100%, it's supposed to be 43.4, but when we measure it, and it would be 35%, well, what we can do, looky here, is take that 35 over the 43, which would be 100% pure. So 35 divided by that 43.4 times 100, this is 80.6% sodium carbonate and 19.4% of whatever the filler was. So you're going to see this problem here and there in the first unit when they're talking about, you've got a mixture. And anytime you see a mixture, start thinking about percent composition and that kind of stuff. All right.